Good morning, everyone, and welcome to this lecture. We are in work power energy. This is lecture number 4, and we are going to deal with kinetic energy in this particular class. Going into a quick recap of what we had done in the previous class, I think we had seen how we can find out work done from the area under force displacement graph. Do we remember this? We had seen that we can find out work done from area under force displacement graph. Area above x-axis gives us positive work, and area below x-axis gives us negative work. So what we are going to do? We are going to continue with the question that we had discussed in the previous class. There was a question that we were trying to do. So we will discuss the same question, and I will give you the same question that we are supposed to do. So this is the question: force F on a particle moving in a straight line is given by this graph. I hope you can see the graph. What is the work done by the particle? What is the work done by the force on the particle for a displacement of 12 meters? So this is the first question, and I hope all of you do this. I'll give you 2 minutes. Try this question. Tell me the answer. You remember how to find out the work done? Yes or no?
Sir.
Okay. So this is the question. It is the question that we were discussing in the last class, and this class begins with the same discussion. So I'll ask you to solve this question and get the answer. Everyone can see this question, yes or no? Here is the question. Everyone can see it now? Okay, I'll give you 2 minutes to solve it. Yes, anyone has any answer for this one? What is the work done by this force? Anyone has the answer for this one, beta? No one? No one knows the answer? Anyone knows the answer? I've given you enough time to solve this. No answers. It looks like you people have stopped studying. It's very bad. We have discussed it so many times. How do you find out the work done from the graph? Please tell me. Anyone remembers? How do you find out the work done from the graph? How do you find out the work done from the graph, beta? No one knows that one as well. Okay, then I'll give you 5 minutes to go through what we had done in the previous class. No one knows, then you'll have to study. So go back and study. I'll give you 5 minutes. Study and then tell me the answer. Go through what we had done in the previous class. Go through the examples. Let me know once you are ready to solve the question. Let me know. I am waiting for you. This is the answer. 13 joules. Area of a rectangle and area of a triangle. You had to add up and get the answer. Everyone, please note it down very carefully. I'm going to give you one more question so that you can practice enough. I'm really very disappointed with your attitude these days. I hope that better sense will prevail. Has everyone noted this down? Okay, good. Let's get over it and let's begin on a new note. And this is the next question, and I hope that everyone gives me an answer for this particular question. Okay, so this is again, I'm trying to draw a force X or a force displacement graph. And the graph is like this. It goes here like this, then it comes here like this, then it goes here like this, and it comes here like this, and it goes like this. This is 0 in terms of distance. This is 2, this is 3, and this is 5. This one is let us say 4, and on this side it is, let us say, -2. Now you have to find out the work done by this force from 0 to 5 meters. Find out the work done from 0 to 5 meters. And I want everyone to try this. You get an answer, wrong answer, right answer, it doesn't matter. What matters is that you try and understand how it is done. One of the question is going to come on graph. It may be a question of force displacement and find out the work done. It can be a question of velocity time and finding out the displacement. Both the things are same. Velocity time graph, above time axis, area is positive. Below time axis, area is negative. Force displacement graph, above x-axis, work done is positive. Below x-axis, work done is negative. So this is the same question Whether you call it force displacement graph, work done, or velocity time graph, distance and displacement. So I'll give you 2 minutes. You already know the formula. Everyone knows the formula. Apply them correctly. Get the answer. And here I must tell you how much is the force. So this is 2. Apply the formula. Get your answers. Everyone.
Six joules, sir.
Well done. We have an answer. Good. Anyone else with any answers? 6 joules. Shall I solve it? Everyone got their answers? Boys, girls? Okay, girls have woken up. Boys? Anyone got any answer? Okay, they are trying. I'll give them 1 more minute. Okay. How are we supposed to do this? We just have to find out the area. Let us mark this area. Let me call this area as the green area. How much is the green area? This green area is the area of a triangle. How do you find the area of this triangle? Can anyone tell me? How do you find the area of this triangle?
Half into base into height.
Very good. What is the base?
2.
Base T. Well done. How much is the height?
4.
Height 4. Well done. Will it be positive or will it be negative?
Positive.
Why positive?
Above the x-axis.
Good. So this becomes plus 4. Very good. Let us now move on to this blue area. This is a rectangle. Okay. What is the area of a rectangle?
Length into breadth.
Length into breadth. Well done. What is the length of this?
1.
1. You can call this as the length. 1 multiplied by how much is the breadth or height, whatever you call it?
-2.
It's already coming minus. So will this area be positive or negative?
Negative.
So -2 joules. Let me also write the unit. Now we come out to the third one, this pink area. How much is this pink area? Again, it's a rectangle or it's a square, whatever. How much is the length?
2.
5 minus 3, 2. Multiplied by how much is the height?
2.
2. and it would be positive. You just need to
4
add up
plus
now.
4.
Oh, 2 plus 2. See, anyone can make a mistake. I wrote 2 plus 2 as 4. It is 2 plus 2 as 8. It is 4. Anyone can do a mistake. How we realize our mistake is when we do a question and then we understand what mistake we are doing. And then we should not repeat that mistake. That is what you have to understand. Now we just add 8 plus 4 plus 4 is 8. 8 minus 2, the answer would be work done from 0 to 5 is plus 6 joules. And that is the answer that we were looking at. And this is the most difficult question that you can get in your exam. Just have to find 2 or 3 areas and we are done. Everyone understands this? Yes or no? Okay, boys? Great, great, great. Okay, chalo, I'll give you one more last so that everyone gets the answer and we understand how simple it is and what we were doing and why we were doing it. We could have done it easily. Anyways, every day you learn something new. So now I have this. Okay, I've made a small one. So let me make a bigger one. Let me make it with my own hands. Okay. So this is my this is my displacement, and this, let's say this is my force, and then I make the graph like this. Then I make the graph like this, then like this, then like this, then like this, then like this. Let me say that this is 2 newtons, this is 0, this is 1 meter, this is 4 meter, this is 6 meter, and let us say this is 2 newton on the negative. No, let me make it different. 2 will look same. Let me call this as 4 newton. So this is the new force displacement graph of any force. You have to find out the work done by this force from 0 to 6 seconds. 0 to 6 seconds. You have the question. The question is in front of you. You've got 2 minutes to give me the answer. Everyone is there. We are back. Boys, we are back in the class. Everyone can see this question. Great, great, great. I see you. 2 minutes you have. Simple question. Solve it so that we can move ahead in life. Well done. I hope everyone can see the question and everyone is solving the question. Good. I've seen the result of your last Sunday test and I can see there is a remarkable jump in the marks in all the subjects. That's good. That's a good sign. Actually, I can see people getting very high marks in physics as well, but we have to improve further. And if we get lose at any point in time, we must be strong enough. Slowly and steadily, we have to climb up. And I hope that your marks will get better in the next exam, and better in the next exam, and better in the next exam. Every day they have to improve. Everyone got the answer for this? Can't hear you, beta. Anyways, I think you have got an answer. That's good. You get an answer, that means you have tried. You can speak, you can tell me the answer, that means you are confident of your answer. That means you have confidence in yourself that you have done it correctly. That is what we need. Confidence, whatever the answer is. Everyone does not know everything. If someone puts a quantum equation in front of me, I will know nothing about it. And I will not be confident to say anything about it. That tells the other person that I know nothing about quantum physics. But if I know something, I will be able to say that much at least. Okay, I know about this. This is the Schrodinger's equation. This is the Schrodinger's cat. It is both alive and both dead at the same time. You say, wow, 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 you know quantum physics. But I just know Schrodinger's cat. But that is good enough to understand quantum physics for the beginners. Yes, anyone with an answer? Okay, I think let me intervene and solve this. What you see here in this space, there is no area. You understand? There is no area because the force is 0. There is no area here. So you cannot calculate the area of this one because the area is 0. Then you have got this diagram. This is actually a trapezium. Now you can find out, you can remember the formula of a trapezium and find out the area of this trapezium. But I just don't want to confuse you with so many formulae. So if you don't remember the formula of trapezium, what you do is you break it up. Every trapezium can be broken up into a blue rectangle. This is the blue rectangle. This is the blue rectangle. And I have not given you the point here. That is the problem. That means this question cannot be done with this blue rectangle and this, because the only way this question could be done is if you know the area of the trapezium. I think you don't know the area of the trapezium. So to help you out, I will give you this as, I thought that you might know the area of trapezium. You don't know it. So I'll give you this as 3. Now you can find out the area of this triangle. What is the area of this triangle? Area of this rectangle, the blue one. Its base or its length is 2. Its height is 2. 2 multiplied by 2. This becomes 4. The blue area becomes 4. Now let me move on. I've broken it up into an area of a rectangle and a triangle. This is the triangle. I can now find the area of this triangle as well. Half, base is 1, height is 2, half into 1 into 2, this becomes 1. All of these areas are positive. Let me move on to the pink one. This pink one is below x-axis, below the displacement axis, as you can see. So this area is going to be negative. And how much? The length of this is 2. The height of this or breadth of this is 4. So 2 multiplied by 4, and I will take it as -8. The below one is -8. The above one is 5. So the answer of this becomes minus 5 minus 8 plus 5 minus 3 joules. Do we understand this? Yes or no? Now, just to remember, just for your sake, I'm giving you the formula for a trapezium. So you can remember this formula. If any question comes where you don't know this side, you should be able to find out the area of the trapezium without any. You can find it out this way as well. You can find it out this way as well. What is the area of a trapezium? If I call this as the area of the trapezium, area of the trapezium is half into sum of parallel sides, which is a plus b, multiplied by the height h. So you can use this formula as well. If you don't want to break it up into a rectangle and a triangle, you can use this formula and get your answer for the trapezium. Okay, anyone got this? We are doing so many questions on this because I know that you are going to get a question based on this. I just feel it that way. And that is why I am insisting so much. Sometimes your intuition works. Sometimes what you feel. You can get the same question in the examination hall. Anyone got this? Yes or no?
Yes, sir.
Good. Let me see if I can get one more question. Do I have a question? Yeah, no, but I have a question. Okay, so I can give you that one because I can't go any further. If I go any further, I will not be able to cover it. So I'll give you one more question on area of the graph. We do so many questions so that if this question comes in the examination hall, we are able to do it. This is the question now. This is 0, this is 3, and this is 5. You have seen a question in one of your previous papers where the force and displacement were given in this fashion. So you have to find out the work done by this force from 0 to 2 seconds. From 0 to 2 seconds, 0 to 2 meters, sorry. 0 to 2 meters, you have to find out the work done by this force. I'll give you 2 minutes to solve this. Yes. Do we have any answers? Anyone? No? Just because the diagram has changed slightly, we are not able to get answers. Again? Anyone? Or shall I do it?
9 joules, sir.
9 joules, sir. I don't know the answer. I'm not so brilliant. So I will just try to solve it. I don't understand how to do it. So what I will do, I will break it up into two diagrams. What are these two diagrams? One is my blue thing. This blue is a rectangle. So I can find out the area of this rectangle. Can anyone help me finding out the area of this rectangle?
Length into breadth.
Tell me answer. What is the length? 2. What is the breadth? 3. 2 into 3 is 6. 6 joules is the area of this. Then I can now simply find out the area of this one, this pink gentleman. What is the area of this pink gentleman? This is basically your
Half into 2 into 3.
triangle. Half into the base is 2 and the height is
3.
3. How did you get 3? How did you get 3? See, this is 5 and this is the height. How did you get 3? This is 5 minus 3. 2, bacha. 2. This is 2. Height is 2. Do we understand this?
Yes, sir.
Half into 2 into 2. So it becomes 2. So the answer is 6 plus 2, 8. That is the answer. You could have done it in this way, or you could have treated this entire thing as one trapezium. You could have treated this entire thing. You can see that it is nothing but one trapezium like this. It is one trapezium like this. Yes or no? So you could have find it out by like this. Half into sum of parallel sides. This is one parallel side and this is the other parallel side. One parallel side is 3. The other parallel side is 5. Half into sum of parallel sides, 3 into 5, into the distance between the parallel sides. The distance was 2. This is the distance between the parallel sides, 2. So 2 and 2 will get cancelled and straight away you will get the answer as 8. So you could have done it by the formula of the trapezium, or you could have done it by breaking up into a rectangle and a triangle. Do we understand this? Since I saw this question in the previous papers, so we did it. Don't get confused. It's always either a trapezium or a rectangle or a square. You can't get anything apart from that. So I've covered all types of question that can come. You will get at least one question on graph where you will have to find out the area of the graph, whether it is velocity time graph. To find the area, you get displacement or distance, or whether it's force displacement graph, you find the area and you get the work done. This is not it. There are going to be other graphs as well, where you can find out from the area of the graph between force and time. Force and time, the area gives you impulse. So one question you should get on graphs, and that is why I spend so much time on graphs. In the next class, we'll move ahead and start with what we are supposed to start today, but could not. Anyways, we'll start with the next topic, which is energy. And I hope you have enough energy. And when you come tomorrow, eat some healthy food so that we have enough energy to deal with energy. So I'll see you in the next class. Take care. God bless all of you. And please, please work. And please, if you don't understand anything, please tell me, beta. If you don't tell me, I won't be able to help you out. We are putting in a lot of effort, lot of time. Your mom and dad are putting in a lot of money as well. Please let us give it our full try, and I'm sure you will be able to get a very, very good government college. I can assure you that. Just keep on working. Let me know if there's anything that is troubling you. Take care. Bye bye.
Bye, sir.